Hello everyone and welcome to NS Online Education. My name is Ravin Kumar. Today we are covering water in biochemistry, and in that we are discussing a very important property, that is ionization of water. This is important because after this we are going to discuss protein and amino acids, and you know that few amino acids are charged amino acid, or you can say that they can break into ions. Okay, and we have to find out that what is the pK, what is the buffering action of that amino acid or that protein. And to understand that buffering action, first we should know what is buffer, and for that we should know what is the pH. Okay, so in this video we will discuss ionization of water, and then we will discuss what is the K equilibrium constant and what is the pH and how to determine pH. Okay, so this will clear our basics about all these things, and then we will go to higher concept. Okay, we will also discuss some previous year question from DBT, because in GATE exam they usually ask question from amino acid, but to understand the basic concept we first start with ionization of water. Okay, so let's begin this video. So pure water is slightly ionized, means that water molecules having a slightly tendency to undergo a reversible ionization, as you can see in this equation. This is the water molecule H2O, and it breaks into H plus and OH negative. Okay, H plus is the proton, because after removing an electron from hydrogen, what left is a proton. Okay, so that's why it is called a proton. And then we have a hydroxide ion, that is OH negative. Okay, so similarly, like other salt molecules like NaCl, or acids like HCl, or like bases like sodium hydroxide, NaCl can break into Na plus and Cl minus. The difference is there is one metal ion and another is non-metal ion. When we comes to acid, there is one proton plus a non-metal ion. Okay, and in bases it is one metal ion plus a hydroxide ion. Okay, so that is the difference between salt, acid, and what we call bases. Okay, and now you can clearly understand that for a salt we must have a metal and a non-metal, for acid we must have a proton to donate, and for base we must have a hydroxide ion to donate. Okay, so this is the difference between salt, metal, and non-metal. Oh. Now the next important thing is that this free proton do not exist in solution. So what happens that this proton will bind to another water molecules and form a hydronium ion H3O plus. Okay, allow me to write the equation. 2H2O will give you, because now we need two water molecules. So when one water molecule break and release this proton will bind with another water molecules and form hydronium ion, and what left is hydroxide ion. So this is what happening inside water. Okay, few of the water molecules break into ion, and how many water molecules break into ions, that we can find out, and that we will discuss in later slides. Okay, now this property of water to break into ions is because of one of the most important property of water, that is hydrogen bonding. Like all other properties of water is influenced by hydrogen bonding, similarly this ionization property of water is influenced by this hydrogen bonding, because hydrogen bonding allow these water molecules to break into ion instantaneously. Okay, as you can see over here, these water molecules, let me highlight these water molecules. So this is our first water molecule, and this is our second water molecule, and as you can see that both of these water molecules are uh, connected through this hydrogen bonding. Okay, so because they are already in contact, what happens that this ionization happens instantaneously, and this water molecules will break into hydronium and hydroxide ions. Okay, so because this hydrogen is already in contact with oxygen, so it is easier to break this water molecule, and as a result we will get a hydronium ion and a hydroxide ion. Okay, so hydrogen bonding play a very important role in water because of it. um, Water having a very high boiling point and melting point as compared to other solvents like ethanol and methanols, because in order to change the state of water we must break these hydrogen bonds. You must know that in ice water forms four hydrogen bond, because water molecule can form only four hydrogen bond with the neighboring water molecules, but in case of liquid water it is uh, 3.4. This is the average. Okay, so the average is 3.4 because hydrogen bond forms continuously and breaks continuously. Now the next thing is proton hopping. So what happens is when this hydronium ion form, so it is possible that it is already in contact with other water molecules, as you can see over here. By contact means hydrogen bond. Okay, so it is again easier to donate this hydrogen to these water molecules as a proton, and as soon as it gives this hydrogen to this water molecule, this become hydronium ion and this become again water. Okay, because it donated the extra proton. Okay, now again this water molecule that I highlighted may in hydrogen bonded with another water molecule. Okay, and if it is, then this will also donate this hydronium ion to this water molecule, and this chain will go on. Okay, so that's how this proton moves in water, and that we call proton hopping. And because of this proton hopping, the proton can travel over a long distance in a remarkably short time as compared to other monovalent cations like sodium and potassium. Okay, okay, this is possible because as I said that water molecules is on an average 3.4 hydrogen bonded with other water molecules. Okay, so I hope the concept is clear, how water ionize and what is proton hopping and what is hydronium ions. And one more thing I want to highlight is that because of this proton hopping property, a molecule can affect the property of other molecule without a direct contact with it. So this property is very important, and this we will discuss when we cover techniques. Now the next important concept is equilibrium constant, and that you have already read in class 12th in chemistry, and from there you know that most of the mixture or solution reactions are in equilibrium. By equilibrium means that the rate of forward reaction and the rate of backward reaction becomes same, and because the rate of backward and the forward reaction becomes same, there is no net change in the concentration of A and B and C and D. Okay, so if you don't know what is equilibrium, allow me to explain you with an example. So consider that here A and B forming C and D. Okay, so first I will write what will the concentration at equilibrium. Consider that by doing experiment that I determined that at equilibrium when there is no net change in the concentration of A and B and C and D, means neither the concentration of A and B decreasing and nor the concentration of C and D increasing. Okay, so at this point I determine the concentration, and what I get to know that at equilibrium the concentration of A is 4 molar. Okay, and B is 4 molar, then C is 2 molar and D is 2 molar. And if we consider that the solution is of 1 liter, then we can say that 4 moles of A, 4 moles of B, 4 moles of C, oh sorry, 2 moles of C and 2 moles of D. Okay, so this is the concentration we will get at equilibrium. Okay, now if you start let's say with A and B. Okay, if you start with A and B as like you have 6 mole of A and 6 mole of B. Okay, if you start with this condition, so regardless what is the starting concentration of AB and CD, you will always reach to this equilibrium condition. Means if you start with 6 mole of A and 6 mole of B, then again after some time you will reach to the condition where you will get 4 moles of A, 4 moles of B, 2 moles of C and 2 moles of D. Okay, and if you start with 6 mole of C and 6 mole of D, then also you will reach to the equilibrium, and there you will get the same concentration of AB and CD. Means you will get 4 moles of A, 4 moles of B, 2 moles of C and 2 moles of D. So no matter what is your starting point, you will always reach to a point when there is no net change in concentration. By no net change, I didn't mean that there is no reaction going on. A and B are continuously converting into C and D, but C and D are also converting back into A and B. If we consider that 10 molecules of A and B converting C into D, then the C and D will are also converting into and B by the same amount, and that we call equilibrium. Means the rate of forward reaction and the rate of backward reaction become same, so there is no net change. Okay, now the thing is, we don't always start with this same concentration. We may consider that we will start with 12 moles of C and 12 moles of D. Then what will be the equilibrium concentration? So in that case, the equilibrium concentration will be, by considering our example, is 4 to the 8, 8, and this will be 2 to the 4 plus 4. Okay, so this will be our final concentration at equilibrium. So you can see that by changing the initial amount, the concentration at equilibrium is changing. So but we can see that the ratio is not changing. Okay, and that ratio is equilibrium constant, and we determine this ratio by using this formula. Okay, so here you can see that K equivalent is the ratio of product of products okay, and product of reactants. So over the top we have C, which is the product, and this is the concentration of C at equilibrium. Then we have concentration of D at equilibrium, and at the bottom we have reactants. Okay, and so this is the concentration of A at equilibrium, and this one is the concentration of D at equilibrium. So we have to find the product of reactants, and then our product of product concentration, and from that we will get K equivalent. So this ratio will not change. Okay, let us find the K equivalent for the example that we have done over here. Consider that this product concentration is 2 into 2 over here, and the product concentration is 4 into 4. So 2 to the 4 and 4 for just 16, or you can say that it will be 1 by 4. Okay, so for this concentration, the ratio is 1 by 4. But what about this? Let us find. So this will be 4 into 4 divided by 8 into 8. Okay, you know that 4 times 2 is 8, 4 times 2 is 8. You will get again 1 by 4. So you can see that the ratio of the product and reactant concentration for equilibrium reactions is always same, and that is equilibrium constant. That is why we are calling it a constant. Okay, but it also depends what is the temperature and what is the pressure and so many things, but that is out of our scope as of now. So let's move on. Now we have to find out what is will be the equilibrium constant for water, because we are discussing ionization of water. Okay, so we know that the reaction for water is H2O will give us a proton and a hydroxide ion, and as I said that equilibrium constant is the ratio of the product of product concentration and to the product of reactant concentration. So here for this reaction, our product is H proton and hydroxide ion, and the reactant is water, H2O. Okay, so K equivalent will be H plus OH negative divided by reactant, that is H2O. Okay, you always have to put them in the bracket. Bracket means we are taking concentration of this molecule. Okay, we may don't know what is the concentration of proton or hydroxide ion in water, but we know what is the concentration of our water. Okay, one more thing is that the K equivalent only takes the value of this concentration in molarity. So we have to put the concentration of water over here in unit of molarity. So you know that the formula of molarity is number of moles. We have discussed this a lot in bioprocess. Number of moles divided by volume of solution in liters. Clear? Now, we may don't know what are the number of moles for 1 liter for water. So we have to break it into more simpler form, that is mass divided by molar mass. Okay. So how we find number of moles? By dividing mass with its molar mass. Volume of solution in liter. Clear? Now, if we consider that the volume of solution is 1 liter, then what will be the mass of water for 1 liter? So we know that the density of the water is 1 kilogram per liter. Okay, and we can also say that it is 1000 gram per liter. So we can write it over here, 1000 gram for 1 liter of water. Then we only have to divide it with molar mass, and you must know how to find the molar mass by using simply the molecular weight of water, and which is 2 plus, and for oxygen it is 16U, so the total is 18. Okay, so this is the molecular mass of water, which is 18 U is the atomic mass unit. So what will be the molar mass? The only difference is of unit. For molar mass we write it as 18 gram per moles. If you don't understand the concept of molarity, there is a link in the description of my video where you can understand it in more detail with some examples. Okay, so moving on. So the molar mass of water is 18 gram per moles. So if we write it over here, let me erase this. Yes, so 18 gram per moles. Okay, dividing gram with gram, and we will left with moles per liter, and that is the unit of molarity. Okay, so by dividing 1000 with 18, use your calci. 1000 divided by 18, and it is 55.5555 and so on. Okay, so answer is 55.5, and unit is moles per liter, and this moles per liter we can write it as capital M. Okay, so here you can see it is 55.5, and this is how you get this value. I hope up to this point everything is clear to you. Moving on, by rearranging this equation, by taking this value, let me change the color of my pen. Yes, this one. So by taking this value over here, we will get this equation, that is 55.5 molar K equivalent equals to proton concentration into hydroxide concentration, and this product we call Kw. So what is Kw? Kw is simply the ion product of water, and what are the ions? Proton and hydroxide. Okay, now if we know the value of K equivalent, we can find the value of this product, yani ki we can find out the value of this Kw. So we can determine K equivalent by electrical conductivity measurement of pure water. Okay, and from that we know that the value of K equivalent is 1.8 into 10 to the power minus 16 molar at 25°C, means at room temperature. Okay, so by simply putting this value in this equation we will get this 55.5 molar into 1.8 into 10 to the power 16 molar, and from this we will get 1 into 10 to the power minus 14 molar square. This is amazing to get this number because this number makes our calculation very easy, that we will see in our coming slide. Okay, so that means the ion product of water is 1 into 10 to the power minus 14 molar square. Molar square is important because we are multiplying two molar units or two molar quantities. Okay. So before moving forward to determine the pH of water, first we have to understand what is pH and how to determine it. Okay. So the pH, you simply know the power of hydrogen, but it is not true. The pH is the negative logarithm of hydrogen ion concentration. As you can see in this formula, pH is equals to negative log of H plus ion concentration. Okay. If you want to remove this negative sign, you just have to put this concentration of H plus at the bottom. Okay, that means if you know the concentration of H plus ion, then you can determine the pH for the solution. So let us take an example to understand it more clearly. So if we consider that our solution having 10 to the power minus 4 molar ions of H plus, then we have to determine what will be the pH. So pH is the negative log of H plus. So if you know the concept of log, you can easily find out what will be the pH, but if you don't, then it will be difficult, but I will make easy for you. Consider this example. What is the power of this 10 in order to get 100? Okay, you just have to answer what is the power we should use over here in order to get 100 as our answer. So your answer will be 2 because 10 square is 100. Easy. Again, what is the power of this 10 in order to get our answer 1000? Okay, so again it is very easy, your answer will be 3. So what you are doing, you are finding log of this 100 and 1000. This is log. Log is simply what will be the power of uh, 10 in order to get this value. Okay, so what we call this 10, 10 is the base of this log. So if it is not mentioned, it is obvious that the log having a base of 10. If there is some other value, they will write it as log 2. For that means we have to find out what should be the power of 2 in order to get our answer 4. So in that case it is 2 because 2 square is 4. Clear? I hope I made it easy for you, but our goal is to find out the pH of this solution which having this concentration of H plus. So to determine pH, we will use this formula minus log H plus. So the concentration of H plus is 10 to the power minus 4. So we have to take it log. So as I said, that log is the power of 10 in order to get this value. So what should be the power of 10? Minus 4. So pH will be equals to minus, and log H plus is minus 4. So our answer will be minus minus plus, that is 4. So the pH for this solution is 4. Okay. So now we know that for 10 to the power minus 6 molar concentration of H plus, the pH is 6. For 10 to the power minus 5 molar solution, the pH will be 5. For 10 to the power minus 4 molar H plus concentration, the pH will be 4. So by knowing the concentration of H plus in the solution, we can determine its pH. Now the next point says that the two solutions differ in pH by 1 pH unit, means that one solution has 10 times the H plus concentration of the other. We can understand this with our examples that we have already done. So as you can see over here, that the concentration of H plus is 10 to the power minus 4, and over here it is 10 to the power minus 5. Okay, so and the difference in the pH is of 1 unit. So if we divide 10 to the power minus 4 with 10 to the power minus 5, what we will get? We will get the value minus 5 of 10. Okay, so the answer will be 10. So you can see that this pH 4 having 10 times concentration or 10 times more H plus ion as compared to the pH 5 solution. Clear? Similarly, if you have to find out what will be the difference of H plus ion concentration for this one is for 1 pH unit, and what will be for 2 pH unit, means between pH 4 and pH 6. So simply divide it these two values. So 10 to the power minus 4 is the bigger value, so I will write it at the top, and 10 to the power minus 6 is the smaller value. So if you divide these two values, minus 6 will go up, it will become plus 6, plus 6 minus 4 will give you 2. So that means 10 to the power 2, and 10 to the power 2 is 100. So you can see that the difference in H plus ion concentration for the difference of 2 pH unit is 100. Similarly, for 3 pH unit it is 1000. Now moving forward, you can see over here, this is our pH scale from 0 to 14. If you having a pH of 7, then that means the solution is neutral, and if you having a pH less than 7, that it means it is acidic. As we have seen in this example, this one having a 10 to the power minus 6 molar H plus ion, so the pH is 6. And as the concentration of H plus ion is increasing, because you can see that negative value is decreasing, that means the value is increasing. Okay, so as we moving down from 10 to the power minus 6, 10 to the power minus 5, 10 to the power minus 4, the pH is decreasing. The decrease in pH doesn't means that H plus ion concentration is decreasing, it means that H plus ion concentration is increasing, because we are taking over here negative sign. Okay, similarly, if the solution having a pH greater than 7, then it is alkaline, or you can say that the solution is basic. So you already knew this concept. And one more thing, if the pH of your blood is below the physiological pH, then the condition is acidosis. Physiological pH is 7.4. Okay, this is the normal value for our blood. So if the pH is below 7.4, then the condition is acidosis, and if the pH is above this 7.4, then the condition is alkalosis. Okay, extreme acidosis and alkalosis can be life threatening. Okay, so you can read this in more detail in Lenin's book. Okay, now we will determine the pH of water that we already know is 7, and which we call neutral pH. But why it is 7, that we are finding over here. So to determine pH, we know that the formula is minus log the concentration of H plus ion. So if we know what is the concentration of H plus in water, in pure water, then we can determine its pH. Okay, and for that we will take help of this Kw, which is the ion product of water, and we determine its value in the previous slides. So the Kw is the ion product of water, which is H plus and OH negative ion, and we know that water H2O, when it's break, it gives H plus and OH negative ions in equal proportion. Means if it gives 1 mole of H plus, then it will give 1 mole of OH negative ions. Okay, as both are in equal proportion, that means H plus is equals to the concentration of H plus is equals to OH negative. And if this is the case, then we can write H plus into OH negative as either as H plus square or as OH negative square, because both having same value. Clear? Like 2 into 2 is 2 square. Similarly, H plus having the same value as that of OH negative. So if we multiply, either we will get either we can write it as H plus square or OH negative square. But our interest is in H plus, because we need concentration of H plus for to determine pH. Okay, so we want to find out the concentration of H plus. So H plus ka square will be equals to Kw, and if we remove this square from here, what will happen with Kw? Under root. Okay, so under root will come, and we know from previous slide that the ion product of water is having the value of 1 into 10 to the power minus 14 molar square. Okay, so by taking under root of 1 into 10 to the power minus 14. So 10 to the power minus 14 the root is 10 to the power minus 7. Okay, and you can also see that this square is also removed because of this under root. Okay, so the concentration of H plus and OH negative ion in pure water is 10 to the power minus 7 moles. Is that clear? Now, as we know the value of H plus concentration in water, we can determine its pH by using the same method that we discussed in the previous slide. So pH is equals to minus log H plus. So it is equals to uh, minus log bracket 10 to the power minus 7. So log is what? Log is simply what will be the power of 10 in order to get this value, which is 10 to the power minus 7. So the power will be minus 7. So minus 7, and that will give you minus minus plus, and so the our answer is 7. Okay, so the pH of water at 25 degrees Celsius is 7 for pure water, and this is the neutral pH. Now I want to move your attention to this table. This table will help us to understand the concept of acid, base and neutral solution. You know that acid and bases are polar molecules, and so they tends to dissolve in polar solvents like water. Okay, and for water the value of ion product, which is Kw, is 1 into 10 to the power minus 14, and this is a constant value, means this value will not change. Okay, so why it is not changing? Because the reaction of H2O to break into H plus and OH negative follows equilibrium. So okay, so this will adjust. If H plus concentration increase, automatically OH concentration will decrease, but this value will not change. Okay, and alternatively, if the OH negative concentration increase, the H plus concentration will decrease, but this value will remain same. So this is what is shown in this table. Here it is the H plus concentration. Here they have mentioned the pH of the solution, and here they mentioned the OH negative ion concentration. Okay, so we will start from here. Here you can see that the concentration of H plus is 10 to the power minus 7. Then the concentration of OH negative will also be 10 to the power minus 7, because here we have seen that for pure water the concentration of H plus and OH negative are same, and from that we determine that the H plus and OH negative is will be 10 to the power minus 7 molar for pure water. Okay, and at this point, because the H plus is 10 to the power minus 7 molar, so the pH will be 7. Now, if we move in this direction, means if we increase the concentration of H plus, the OH negative concentration will automatically decrease. Okay, so here you can see that we are increasing the H plus concentration, and so the pH value is decreasing. pH value is decreasing because it is the negative log of H plus. Clear? But the concentration of OH negative is decreasing. Okay, as you can see. So that means if there are more H plus as compared to OH negative, then the solution is acidic. But if the H plus concentration decrease, because as I said, this value will not change. So if we decrease the concentration of H plus, then the OH negative concentration will automatically increase in order to attain this equilibrium. Okay, so as you can see, the as the H plus ion concentration is decreasing, the pH is increasing, and the solution become more and more basic. So what happens when we add acid to water? The concentration of H plus ion increases. But in order to maintain this value of 1 into 10 to the power minus 14 molar square, the OH negative ion binds with the H plus and form water molecules. And because of that, the concentration of OH negative ion decreases, and so there will be less OH negative ion in water as compared to H plus ion, but this value will remain constant. Okay, similarly for bases, so when we add base in water, what happens? The OH negative ion concentration increases, but in order to maintain this value, these H plus ion bind with extra OH negative ion to form water, and that's how there will be less H plus ion in the solution as compared to OH negative. So I hope now you understand the concept of acid, base and water, why it is neutral pH, because the concentration of H plus and OH negative are same. Now let us solve few example. This example is from Leninger. What is the concentration of H plus in a solution of 0.1 molar NaOH? See, NaOH is a strong base, so it will completely break into ions as soon as we dissolve it in water. So it will form Na plus and OH negative. Okay. So as the concentration of NaOH is 0.1 molar, so will be the concentration for Na plus ion, and similarly for OH negative it will also be same. Okay. Now, so we now know the concentration of OH negative will be 0.1 molar, and we know that Kw will be constant for water, ion product of water, which is H plus plus OH negative. We know the value of Kw is 1 into 10 ki power minus 14 molar square, which is equals to H plus, and now we know the concentration of OH negative is 0.1 molar. Okay. uh, then we will divide this value with 0.1 and we will get our answer. So 10 ki power minus 14 molar square divided by 0.1 molar, and that will give us the concentration of H plus. And by removing this decimal, and it will give you 10 multiplied 10 ki power minus 14, so it will be 10 ki power minus 13 molar. मोलर से ये यूनिट कैंसिल हो जाएगा, and it will give us H plus. So this is the concentration of H plus in our solution, and if you want to find out the pH, so pH will be 13. Okay, that we have already discussed how to calculate. So this is one of the example from Lenin's book. Moving forward, this is another example from Lenin's book. What is the concentration of OH negative in a solution with an H plus concentration of this? So H plus concentration is given. You have to find out OH negative concentration by using the same method as we discussed in the previous example. So try to solve this by yourself. Then this example is from DBT 2019. The pH of a 0.001 molar HCl solution in water is. So it is very easy. Again, the HCl is a strong acid. It will completely ionize. So the concentration of H plus will be how much? 0.001 molar, which is equals to 10 ki power minus 3 molar. Is that clear? So you know how to find the pH. pH is negative log of H plus. So it will be minus log of 10 ki power minus 3 molar, and this will give us minus 3, and which is equals to 3. So our answer will be option number C. Now we have to find out what is the pH of 10 ki power minus 8 molar solution of HCl. See, this question is not easy. It is a difficult question, but I will try to explain you easy way. See, if we find the pH by using the same formula that we are using till now, that is pH equals to minus log H plus, and what we did, we just simply put the value of H plus, which will be 10 ki power minus 8 molar, but this will give us a value of 8. 8 means the solution is basic, and we know that HCl is an acid, so it will give an acidic solution. Then why comes 8? Because we are using the wrong method. Okay, so why we were using a wrong method, that I will explain you after solving this question. Okay, so let's solve this question. So we know that the ion product of water is constant, means the concentration of H plus and OH negative ion will always give us a value of 1 into 10 ki power minus 14 molar. Okay, this we know for sure. But what will be the H plus ion concentration? That we don't know. Here the H plus ion concentration is the total H plus ion concentration. Total H plus. Total H plus is will be equals to the H plus from water, okay, and H plus from HCl. Okay, clear? See, The HCl is a strong acid, so it will completely ionize in water and it will give us H plus and Cl negative. That means if we dissolve 10 ki power minus 8 molar of HCl in water, it will obviously give 10 ki power minus 8 molar H plus. So this value we know for sure that it is 10 ki power minus 8 molar. Okay. But now we have to find out what is the value of this H plus water. Clear? And we also know that H plus of water and is equals to OH negative of water. That we also know. Okay, because we know that in pure water the H plus ion and the OH negative ion formed by breaking the water will be same. Okay, so if we consider this is equals to X, that the concentration of H plus of water and OH negative water will be X. So we can put this value over here. So the total H plus will be X plus 10 ki power minus 8 molar. I hope it is clear. Now by putting this value in this formula Kw, so Kw will be equals to H plus, total H plus concentration is X plus 10 ki power minus 8 molar, and this 10 ki power minus 8 molar is for HCl. Then OH negative, we know that OH negative for the value is X, because the concentration of H plus ion because of ionization of water and of OH negative ions will be same. Okay, so this will be X and this will be X. Okay, and the product will be remain same, that is 1 into 10 ki power minus 14 molar square. Now we have to solve this equation to get the value of X, which is the concentration of H plus ion and OH negative ions because of ionization of water. Clear? So we are determining how much water is ionized. Okay, so this will be X into X, X square plus 10 ki power minus 8 molar X, okay, equals to 1 into 10 ki power minus 14 molar square. And you know how to solve the quadratic equation. So by solving this equation we can determine the value of X. So you know the formula is X equals to minus B plus minus under root B square minus 4AC divided by 2A. So either use this formula, and if it is possible solve by mind. So if we put the value, so b is 10 ki power minus 8 minus 10 ki power minus 8 plus minus under root 10 की पावर माइनस 8 का स्क्वायर करेंगे, so that will be 10 की पावर माइनस 16 minus 4, a की वैल्यू है 1, here it is a, and c is on right side, but if we take it to left side it will become negative, so minus 10 की पावर minus 14 under root, okay, divided by 2 into 1. Okay, so we have to solve this, so I'm using calci for this. So 10 की power minus 16 माइनस 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 प्लस हो जाएगा, तो प्लस ब्रैकेट में 4 into 10 की पावर minus 14. Okay, and whatever I'm getting this, I will under root the answer, and this is 2 into 10 की power minus 7. Okay, so I will write one more step for you, 10 की power minus 8 plus minus bracket 2 into 10 की power minus 7 divided by 2. Okay, now either we will add or we will subtract 10 की power minus 8 with 2 into 10 की power minus 7, whichever will give us our right answer. Okay, so first I'm going to add. Okay, so minus 10 की power minus 8 plus bracket में 2 into 10 की power minus 7 divided by 2. So this is giving 9.5 into 10 की power minus 8. So this is the one value after getting addition. What we will get after subtracting? 2 into 10 की power minus 8 माइनस ब्रैकेट में 2 into 10 की पावर -7 and divided by 2. So by doing this, what we are getting a negative value. We don't want negative value because concentration cannot be negative. So this is our right answer by doing addition, which is 9.5 into 10 to the power minus 8, and the unit will be moles. So we have our value of x 9.5 into 10 to the power minus 8 molar. Okay, so now we get the value of H plus ion, uh, which is formed because of ionization of water, and this is the same value for OH negative ion as well. Okay, now what we have to determine, what is the pH. So to find the pH we need negative logarithm of H plus, but this H plus uh, is represent total H plus ion concentration, and total H plus is equals to H plus because of water ionization plus H plus because of HCl ionization. Okay, so for water, because of water ionization, the value is x is 9.5 into 10 ki power minus 8 molar plus, and because of HCl it is 10 ki power minus 8 molar. Okay, if we add these two value, what we will get, we will get 10 9.5 into 10 ki power minus. So this will give us 10.5 into 10 ki power minus 8 molar. Okay, so if we find negative log of this value, so negative log bracket 10.5 into 10 ki power minus 8 bracket close. So this is giving us a value of so pH is 6.9788. Okay, and as you can see, the option 1 is our right answer. So as you can see, now our solution is slightly acidic. Okay, which is true because we used acid, not base. So this is the calculation that we have to perform in order to find the true pH for the solution. But now the question is, why didn't we use this method for finding the pH in the previous example? So I will suggest you to use the same method that we discussed to find the pH for this solution, and you will get your answer. So this is the same question but from 2011. So they love this question, that's why they give it again in 2014. So this is it for this video. I hope you people like it, and so we will meet you in the next video. So see you then. Bye bye.